Good day to all the students. In this class, we see the last class revision, that is minerals and ores difference. Second, definition of concentration of ore, or what is concentration of ore, and then concentration methods. First method, gravity separation method and magnetic separation method. Two methods in this class we see. Next class we see the another two methods. And book back 2-mark question. Explain the following terms with suitable examples. Gengu. Now go for the first part, revision, minerals and ores. For understanding purpose, in a classroom totally 10 students. In 10 students, except 4th students, all the students take the less than 70% of mark. The 4th student take the 90% of mark. Based on that, the 4th student is a first mark student, that is topper. Like that, EFE ion has 1 to 10 minerals. We take all the minerals 100 gram. After the extraction, except this 4th mineral, only less than 70% of, that is 70 gram of Fe is extracted. From the 4th mineral, we get the 90 gram of Fe, that is high percentage of Fe. That 4th mineral is called the ore. That is 1 to 10 students. 4th student take the high percentage, therefore that student is called a topper. Like that, these students are equal to minerals. This 4th student take the more than 90%. Like that, this 4th mineral after extraction has the highest percentage of metal. Therefore, that mineral is called the ore. Now, concentration of ore. In this case, what is concentration of ore means it has three definitions. Both are same. That is a removal of gangus from the ore. That is, what is gangu? In a ore, always combine with non-metallic impurities, rocky and siliceous matters. That is, ore has some of the non-metallic impurities. That non-metallic impurities called gangu or impurities. For example, Fe2O3 for iron ore, Fe2O3 is iron ore. Non-metallic impurity is SiO2. Non-metallic impurities is SiO2. After the concentration, the ore Fe2O3 and gangu are separated. That is called the concentration of ore. That is, ore plus gangu always in joint form. After the concentration, ore and gangu are separated, or simply removal of gangu from the ore. This part has two questions. What is concentration of ore? Second question, what is gangu or impurities with the example? That is the book back question. Explain the following terms with the suitable examples. Gangu. Gangu is non-metallic impurities, rocky or siliceous matter. Example, Fe2O3 is right in this format. SiO2 SiO2 is removed from the Fe2O3 is the example for gangu. Now go for the another part. Concentration methods. First method, gravity separation method or hydraulic washing method. Hydraulic washing method applied for native ore of gold, oxide ores. Example, hematite Fe2O3, tin stone SnO2, O2. The principle is the specific gravity difference between ores and gangue. Ores has the higher specific gravity. Gangue has a lower specific gravity. For understanding purpose, suppose this is a slab. Now we pour the ore with the impurities. Impurities has the low specific gravity. Therefore, it goes on the top. The ore with the impurities mixed with water now pour on the top. Due to the low specific gravity, the impurities on the top, the ores has a high specific gravity, therefore it is stay on this lower part. After the process over, the lighter impurities go away and ores on the bottom of this part. This figure is for only understanding purpose. For exam point of view, we write only the one line. Ore is treated with rapidly flowing current of water. Lighter gangue, that is impurity particles, was washed away by the running water. That is due to the lower specific gravity. The gangue particles are washed away by running water. That's all. In the gravity separation method, totally 3 points suitable for gold and oxide ores. It may be asked in one more question. The principle is specific gravity differences between ores and gangue. And the third point, explanation. Now, second separation method, magnetic separation method. This method is applicable to ferromagnetic ores. Principle is magnetic property is differences between the ores and impurities. 2 examples. Tin stone ore with impurities, that is wolframite. That wolframite has the metallic nature. Second example, chromite and pyrolusite, and the impurities are siliceous matter. In this case, the ore has the magnetic nature. That is ore and impurities, anyone has the magnetic nature. Explanation in the book. Magnetic separation. Explain. This is the picture. In this case, only crushed ore is poured on the electromagnetic separator. Consists of belt moving over the two rollers, of which one is magnetic. The magnetic part ore is attracted towards the magnet and falls as a close to the magnetic region. Non-magnetic part falls away from it. That is important points. This is a magnetic separator, that is electromagnetic separator. This is the electromagnetic separator, in which this is the magnetic wheel, that is magnetic in nature. This wheel is a non-magnetic nature. Now pour the powdered ore at the top of the separator. Now, if we take an example of Fe, in a Fe is the magnetic nature, sands SiO2 is non-magnetic nature. Now, the magnetic nature, magnetic particles are attracted by this magnet. Therefore, the magnetic particles are come up to this region. Therefore, the magnetic particles are come to this bucket, that is magnetic ore. The non-magnetic particles are falls in this region. Based on that, we separate the magnetic ore from the non-magnetic ore. That is called the concentration of ore. Now, in this class, we see the difference between minerals and ores, a definition for the concentration of ores, and gravity separation method and magnetic separation method. Also, the gang with suitable examples. Next class, we will see the another concentration methods, that is leaching and flotation method. Thank you very much.